Hello and welcome to this video on the chemicals that make your soap work. Whether it is hand soap, dish soap, laundry soap, or the degreaser used to clean engines and brakes. All of these soaps need to work against a range of things. Dirt to grease and oxides. Many things that need to be removed with different chemicals because they have different weaknesses, so to speak. This is why your soap has different kinds of chemicals. While some have enzymes of one kind or another, this video will focus on the ways reactions and compatible chemicals can make your things cleaner. The first chemical we'll describe are saponins. These are extremely useful in making water and oils miscible. Without that, things like grease would not come off anything readily. That makes it hard to wash dishes or your car. Saponins help to solve this by separating the grease and other oils and mixing it with water. As most people would be familiar, oils and water do not mix. They will form two very discrete layers. The way saponins work to solve this is like having a duality in its nature. There is a polar side and a non-polar side. Another way to explain this is to say a water-loving or hydrophilic side and a water-hating or hydrophobic side. This duality is called an amphiphilic compound. The two sides create an opportunity for the saponin to interact chemically with the lipids and water at the same time. There are positively charged saponins called anions, with which the most common would be your carboxylates. There are also sulfates and phosphates. The negatively charged version of a saponin is called an anion, and ammonium is the most common example. There are uncharged saponins, and this is best exemplified by alcohol. However, these are not used as often, largely due to the cost and difficulty of them. Surfactants are another common ingredient found in soap. These work by lowering the surface tension. This is done somewhat like saponins. It is another amphiphilic compound. The surfactant has a part of it which is water insoluble and a part which can be immersed and contain oil. What you wind up with is that the surfactant will spread throughout the water and it will create small pockets. This occurs at the point where you find water and oil, or water and air. When this happens, they encapsulate this and create a pocket, and the lipids are kept inside of this, while the water is kept outside. It's fundamentally the same way the cell membranes that make up all the cells in your body work. There is a side that can work with water and a side that can't. By creating a very clear separation and creating a sphere, the non-water liking part can hide inside with the oil and keep it trapped in there where it has no problems, and the water liking side can hang on outside of that without any issues. On top of the two major compounds we've mentioned so far, surfactants and saponins, there are caustic chemicals too. The most common is potash or sodium hydroxide. It can be substituted with potassium hydroxide, but for the most part we'll talk about it in terms of sodium hydroxide. Just be aware that they are fundamentally interchangeable, but there is very niche applications for each at a chemical level. This is a caustic or alkali material. In those terms, it helps to start breaking down protein, and it can do so at very low temperatures. This is one reason why they're commonly found in things like stain removers in particular. It's also particularly useful with anything that's going to make an ester. By hydrolyzing the ester, you can turn it into various other things. Amides and alkyl halides also work in these terms. This means it can break down a wide range of products. That flexibility is why potash is perhaps one of the oldest cleaning chemicals known to humans. The name potash derives from the fact that it is made from ash from fireplaces historically. It was simply mixed with water and used as a mild abrasive, and it was extremely effective. That's why it could be combined with something like lard or fat to create normal bath soap or similar. While it was quite aggressive, given the lack of alternatives historically, this was pretty much your go-to option if you wanted to be clean or be able to clean other things. The next option, and again a common one, is known as washing soda, soda ash, and soda crystals. It very much depends on where you are in the world. All of these are water-soluble sodium salts. The basic formula is Na2CO3. It is very simply a rather reactive chemical. It can either accept hydrogens, it can release an oxygen molecule to become something of a oxidizing agent, the sodium can do its job and salt out. There are many ways this one small chemical can work. This is one reason why it is quite popular to use as a soap material. The chemical reactivity is versatile, and it doesn't have as many drawbacks as potash does. At the same time, it's also not as good. One reason it is commonly added is because it will help to thicken the soap and make it appear more substantial than it would otherwise be. The complex interactions and complementary actions of these four chemicals show you that soap is more than just an assistant to mechanical agitation. These chemicals help to separate oils, dirt, and other material, keep it separate, and better facilitate the cleaning and the cleaning process. Some of them are very old, some of them are relatively new, but they all do the same basic thing. They make soap work. Thank you for watching this video. If you found it interesting, consider liking, sharing, and subscribing. Please post any comments, questions, or suggestions that you have below.